Okay, so let's learn how to add physics to our object in Unity. So here I have a cube already in my scene, and to add physics to this cube is actually really easy. So I just go down here in the inspector and I go to add component. So components are Unity's way of sort of packaging different kinds of functionality up with each other. It's also where you'll go if you want to add your own code to something. So it has a nice search function here. So if I go in and I type in rigid body, you'll see that there's this option for rigid body right here. And this is the sort of component that will add physics to the object. If you go into this component here, you'll find that you can change different properties of the physics. But let's just see what happens when we press play on our game. You'll notice that it switches from the scene view over to the game view after it thinks a little bit. And lo and behold, the cube falls off the screen. Okay, so let's do a little more to make this a bit more game-like. So I'm going to go out of here. I'm going to add another game object to my screen, and this time I'm going to add a plane. So a plane is basically just a big flat sort of 2D object, and I'm going to just move it down a ways so our cube has somewhere to fall. I also have to add a rigid body to this object as well. So I'm going to go back to add component, add rigid body. This one, we don't want it to use gravity. And here's another important thing, is kinematic. This basically kind of locks it into space. This is important for things like floors, moving platforms, those sorts of things. You want it to affect physics objects in your game without sort of being knocked around by those objects. So that's what kinematic means. So if I press play now, it should fall and collide with the plane and then stop falling. So now we have a cube sitting on a plane. Great. Let's get a little more fancy. I'm going to go into one other feature of Unity, which is the prefab. So prefabs are a way to sort of package a game object together and reuse it in the way that you've created it. So like this cube, it has this rigid body that we have added to it. And let's say that maybe it has other awesome things going on with it, and I want to reuse this cube many different times. All I really have to do is go from the hierarchy, drag it into my assets folder, and it creates the prefab of the cube. So now you'll notice that its text turns blue and its icon turns blue as well. This sort of means that now it is now a prefab. And if I go and open it, you can see that I can actually edit the prefab version of it. And when I do that, it will actually change all of the instances of that prefab. So let's say I make it like a flat rectangle. And then I go back out of here. And now you'll see that it would change here as well. Now I didn't change it here in the scene, I changed it in the prefab. Cool. And so now I can easily add more cubes to my scene. Let's add it and then move it somewhere else, maybe above it. We'll do it one more time. We'll move that one even further up. So now when we look at our scene, they all fall. The objects bounce around off of each other. Okay. Another thing that's important to know about the physics in Unity is that it's controlled kind of by two different components. The rigid body affects its motion. The box collider affects its shape in the physics engine, right? So as you can see here, this is controlled by a box collider. There are a few different kinds of colliders. If I actually go into, I'll add a sphere into my scene. I will add a component to that for rigid body, and as you can see, it has a sphere collider. So it's going to be, this is the sort of mathematical object that controls its shape for collisions and for physics. So let's just give that a quick little test. And so now I see our sphere acts like a sphere because of its sphere collider combined with the rigid body. A common thing to do is to change that collider to sort of meet your needs. So one common thing is that you may have a player-controlled object, an avatar, and you want it to be a little more forgiving, say for dangerous objects attacking it. If I go in here and edit collider, I'm going to zoom in, you'll see that I get this little sort of wireframe of the collider itself, and I can actually change its size. Right now it's being locked to its proportions, and I'm going to hold on the Alt key to keep it centered. So if this was the player object, I might want to say shrink the collider somewhat, and that gives the player a little more of a forgiving collision, and it'll be more exciting. They'll see more narrow misses, and if a bullet just barely scrapes the player, the player won't just die and then get mad about dying for sort of a weird deflected shot. So it'll be hard to see the slightly smaller collision that I've created here. So I'm going to make it really exaggerated just to kind of demonstrate what's going on here. So I'm going to make it very small. And when we test, you should be able to see it sink pretty dramatically into the plane as it rolls away. Right, so yeah, see how it's clipping all the way this far into it. Okay, so let's say you want to move your physics-based objects in space, either with keyboard controls or maybe automatically or something. The common way to move objects in some games is to directly affect the transform, right? So changing the X and Y position using code or otherwise. Now, when something is a physics object, if you go straight to the transform and start editing it there, it's going to interact with the physics badly. It's basically like teleporting stuff around. Things might pass through each other or get really awkward. So the best way is using physics-based movement, namely add force. So I'm going to show you how to add a script to this sphere, and we're going to add force to it and watch how it moves differently than the rest of the objects. So the first thing to do is to go down to add component, and we're going to do a new script. And we can name it whatever we want. I'm just going to call it force test. I'm going to create and add that. And as you'll see, a C# file appears in my assets folder. If I click on that, it's going to open up a different program, Visual Studio. This is where you write code for Unity in C#. So this is what a basic C# script is going to look like. It's going to start with these two kind of chunks. This is the start function or method. Anything in between these two brackets will happen one time at the start of the program. Down here is update. This will happen basically over and over and over again, once per frame. So I've prepared some code here. All right, so just to explain a little bit of what's going on here, I've declared two variables at the top of the class force test. If you don't know, up here is simply we're kind of telling Unity what parts of the engine we're using. So you kind of have to know what you're using down here to know what goes up here, but don't worry about that too much for now. Here's where we declare, this is sort of the name of the script, force test. So this is the basic class that we are extending. This has a bunch of built-in things that Unity gives us. It's basically the default game object class. At the top of our class, we're declaring two different variables, a public variable called thrust, and if you don't know what a float is, it's essentially a number that contains decimal points. Next, we're doing a private variable, rigid body RB, just standing for rigid body. So a rigid body is the name of a type of object that we've included in our sphere, and this will allow us to work with it later on. Okay, next chunk, start is happening at the first frame of the scene, and we are doing only one thing here. So we're assigning RB to get component rigid body. So basically this is telling Unity to find that component and kind of assign it to this variable so that we can work with it. And then lastly, we are calling update once per frame. This is automatic. And here we're taking RB and we're using the add force method, which is built into the rigid body class. And so inside of add force, we're telling it where to add the force. This is essentially saying add force in the direction up, and we're going to multiply that by whatever thrust value we give it. This is actually a vector 3. A vector 3 is essentially a three-part number, each representing the x, the y, and the z coordinates. So transform.up is an automatic way of saying 0x, 1y, and 0z. And so then if we multiply that by thrust, we'll get some sort of thrust, in the upwards direction or downwards if we use a negative number. Okay, so let's save our script and go back to Unity. And assuming everything goes well and it compiles properly, we should see that our little script component now has a thrust thing that we can change. So let's change it from 0 to, let's say, 10. And this is sort of the beauty of using a public variable that allows you to access it in the inspector. So if we press play again, we shall see what happens next. So now we can see that the sphere has counteracted the gravity and is now kind of accelerating upwards. That's because in our code, we are applying that force continually to the sphere in an upwards direction. That's not usually the way you'll be moving an object, but it goes to show kind of how adding force affects an object. One of the cool things about add force is that it acts just like force in real life physics, giving an object certain types of acceleration and inertia and momentum and those sorts of things, and interacting with all those in a proper way.